talking about GCF, and then we did difference of squares. And difference of squares works when we have a subtraction sign and we have two perfect squares. And that one was really easy. We just took the square root of both, and it was a plus b, a minus b. The next thing we're going to do is when we have perfect cubes instead of perfect squares. And this one actually works with a sum or a difference. So difference of squares, there is no sum of squares. So if I have x squared plus 9, that doesn't work. But if you have perfect cubes, there's a formula for sum and a formula for difference. And we're going to start with sum. To be a perfect cube with exponents, it has to be divisible by 3. With perfect squares, remember if we took the square root of x to the 10th, that was x to the 5th. We divided by 2. If we're taking the cube root, you divide by 3. So real quick, let's go through and figure out some of our perfect cubes. So now one way that you can see these in a list, if you go to your y equals and you type in x cubed, we did x squared, but if you do x cubed and then you go to your table, starting with, like here's, like 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and we have 125, 216, 343, 512, 729, and then 1000. Those are the first few perfect cubes. And just having them here on the side will just make this easier. Alright, and then, so if I take the cube root of x cubed, that's going to be what? Divide the exponent by 3. The cube root of x to the 9th would be x to the 3rd. The cube root of x to the 30th would be x to the 10th. Dividing by 3. The cube root of x to the 42nd would be x to the 14th. Yep. Cube root of x to the 60th would be x to the 20th. And then the last one will be x to the 100th. If you were taking the 4th root, what do you think you would do with the exponent? Divide by 4. If you were taking the 5th root, you would divide by 5. Yep. So here's the rule for sum of cubes. And it's longer, a little bit more difficult. So if I have a cubed plus b cubed. So a sum, I'm adding two perfect cubes. In one parenthesis, it's a plus b. We're going to get the a and b by taking the cube roots. Not too bad. But then I have a squared minus ab plus b squared. I will not expect you to memorize these like formulas. I will give them to you, but you still have to know how to use them. So the first thing we're going to do is find a and b. So a, we take the cubed root of x cubed, which is what? X. And b, that's the cube root of 27, which is what? 3. So then these other parts over here, I need a squared. If my a is x, if I square that, what do I get? What's x squared? X squared. It's just x squared. Then I need AB. If you multiply these two, what do you get? 3x. And then I need B squared. So B is 3. So what's B squared? Which is what? 9. Yep. And then you just put that together and make sure you follow through with these signs. So it's x plus 3 x squared minus 3x plus 9. And you can check x cubed plus 27 x plus 3 x squared minus 3x plus 9. And since I got matching numbers, I know it was right. I just randomly picked 4. Okay. So let's go to number 12. To find a, we do the cube root of 125, which is what? 5. We've got this list over here. So by 125, it says 5 cubed, so 5. B is the cube root of x cubed, which is x. Good. Okay. So then I need a squared. So my a is 5. What do I get if I square that? 25. AB, you multiply the two. What's that? 5x. And then b squared, what do I get if I square my b? X squared. So my answer a equals x, and then 25 minus 5x plus x squared. Are there any questions? Now you should also always be checking to see if there's a GCF. In both of these, there wasn't. Both didn't have a whole number, and they both didn't have a variable, so there couldn't be a GCF. Number 13, those are different variables. One's an X, one's a Y, so still no GCF. So for my A is the cube root of x cubed. Now you don't have to put this here in the middle. You don't have to write the cube root of x cubed. If you just want to write a equals x, that's okay. B would be the cube root of 216 y cubed. What's that? 6 and y. Yeah, 6y. Because the cube root of 216 is 6, and the cube root of y cubed is y. So if I do a or x squared, that's x squared. AB, what do I get if I multiply these? 6xy. And then b squared. That's really 6y squared. So you have to square the 6 and you square the y. So we would get 36y squared. Any questions on that? So then my answer is x plus 6y, x squared minus 6xy plus 36y squared. And I have to write smaller. Number 14. Is there anything you can divide both 8 and 64 by? 8. You can divide them both by 8. So we have a GCF of 8. Leaving me, in the x, these are different variables, so you can't take out any x's. So it would be x to the 9th plus 8 y to the 21st. And because the 9 and the 21 are divisible by 3, they are considered perfect cubes. The exponent's there. So my A is the cube root of x to the 9th, which is x to what power? The what? The third, yeah, because you divide by 3. B is going to be the cube root of 8y to the 21st. What's the cube root of 8? 2. And then y to the 7th. Good. So if my A is x cubed, if I'm going to square that, that's going to be x to the what? Use your exponent rules. This is 6. 6. When you have exponent and exponent, you multiply the two numbers. AB is just going to be 2x cubed y to the 7th. And B squared, this one's kind of a hard part. 2y to the 7th squared. Where the 2, what's 2 squared? 4. And then I would have y to the 14th. Multiply the exponents. And when you have a GCF, that has to be part of your answer. So we have the 8, and then we have x cubed plus 2y to the 7th x to the 6th minus 2x cubed y to the 7th plus 4y to the 14th. Any questions? I know it's kind of a lot. Number 15. Do we have a GCF?
Yeah.
Yep. What can you divide both of those by?
2.
You can divide them by 2, but you can also divide them by 4. So 4 is the greatest. I'm going to go ahead and write that 4 down here at the bottom so I don't forget it. So my A is going to be the cube root of 125x cubed, which is what? What's the cube root of 125? 5. Right here. So we have 5, and the cube root of x cubed is x. Okay. And then B is the cube root of 1, which is 1. And then we need to find a squared. So what if I do it again if I do 5x squared?
X to the second?
Yep. You do 5 squared and you do x squared. AB, multiply those two. What do you get? 5x. And b squared, what's 1 times 1? 1. So then you put it all together in your formula. 5x plus 1, 25x squared minus 5x plus 1. I want you to try the last 3 problems. So number 16, your A is 2x, B is 5. A squared would be 4x squared. AB is 10x, and B squared is 25. So no questions on that one? Here's number 17. Had a GCF of 2. So that left you with 125x cubed plus, no, 125x cubed plus 8y to the 12th. And so the cube root of 125 is 5. The cube root of x cubed is x, so 5x. The cube root of 8 is 2. And the cube root of y to the 12th, remember you divide by 3, so it'll be y to the 4th. And then a squared, that's like 5x times 5x, which is 25x squared. Multiply those two, you get 10x y to the 4th. And then b squared, 2 times 2 is 4, y to the 4th times y to the 4th is y to the 8th. And you put all that together. Other questions on that one? Let's look at 18. This one had a GCF of 3xy. So you could divide both of those by 3, but they also both had at least one x and they both had at least one y. If you didn't take out any variables, you would not have exponents divisible by 3. And once again, when you took that out, you were left with 8x cubed plus 125 y cubed. So if you want to get that one down, you can. Now, difference of cubes, we're not going to work through these examples, but I'm going to give you the rule. It's almost identical to the sum of cubes. Difference when I have a cubed minus b cubed. So if we have two perfect cubes, but there's a subtraction sign, the only difference is the first two signs are switched. So it's a minus b, a squared plus ab, and the last one stays b squared. So the process is exactly the same. It's just these two signs are switched. If it starts with the minus, it's minus plus. If it starts with a plus, it's plus minus, and they both end with a plus. So we're not going to do those four. But we are going to do the trinomials. I want to get through this one today. And pretty much what we've already done in quadratics. So 23 is going to be really easy. X squared plus 2x minus 24. When you have a trinomial, if there's not a number in the very front, all we have to do is look for two numbers that multiply to be negative 24 and add to be 2. Does anybody know what those numbers are? Anybody? What multiplies to be 24?
64.
Well, let's start at the beginning. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now one of these has to be negative, and I have to add to be positive 2. How am I going to do that? 6 and negative 4. So my factors are x plus 6 and x minus 4. That's one of those things we did in quadratics, but you're going to have to keep doing that. You should get to where you are really good, really quick at these just very basic factoring. That'll help you out. Now number 24, there's a number in front. But before we get too panicked, we might have to use the box method. See if there's a GCF. Can I divide those three numbers by something? No. So we are going to have to do the box method that we did in the last unit. The 5x squared goes in the top left. The 6 goes in the bottom right. And we need two numbers that multiply. Do y'all remember what they need to multiply to be? They add to be negative 11. They multiply to be 30. Because 5, you multiply your A and C. So what two numbers multiply to be positive 30 and add to be negative 11? Negative 6 and negative 5. And so then what we do, if you remember, we look at each column and each row and do the GCF. So if I look at the first column, my GCF would be 5x. The second column, you probably want to say 6. But remember, if the very first one is negative, you've got to put negative 6. And then, what's the GCF of that row? Just x. The only thing they have in common is an x. What about that one? Negative 1. Good. So 5x minus 6, x minus 1. All right, 25. Is there anything you can divide all three of those numbers by? You can divide them all by 2. What about any variables? That 80 doesn't have any, so no. So it's x to the 4th plus 13x squared plus 40. And this one looks new, but when you have an x to the 4th and then an x squared and then nothing, it's just like the one above it, except in your parentheses, instead of just having an x, you have an x squared. So we still are going to look for two numbers that multiply to be 40 and add to be 13. Eight and 5. So it's going to be x squared plus 8, x squared plus 5. Now this last one, this should be x to the 5th. Is there a GCF? Is there anything they all three have in common? They all have an x. So if I take out an x, I'm left with x to the 4th minus 2x squared minus 8. Oh, this last one I didn't include the 2. So we need two numbers that multiply to be negative 8 and add to be negative 2. Anybody? Negative 4 and positive 2. So I have x for my GCF, x squared minus 4. So I'm using my x squares because of that was a 4. And x squared plus 2. And that's where we're stopping today.